Bismillah ar-Rahman ar-Rahim. So this is chapter 6, circular motion and other applications of Newton's laws. So still we are talking about Newton's laws, especially the second law, summation of forces is equal ma. And now we will apply this in a circular motion. So basically, in a circular motion, we have a circular motion in uniform. The first one, it's the easy one, it's a uniform circular motion. Uniform circular motion means speed is constant. Speed is constant. Velocity is changing at a constant rate. Velocity is changing at a constant rate. So in this situation, if you still remember, and you can check other videos before. So here we have velocity 1, and here we have velocity 2. And the direction of the acceleration in uniform circular motion is always pointing to the center. Always pointing to the center. That is the direction. However, the value, the magnitude of the acceleration in a uniform circular motion is v squared over r. And when we apply Newton's second law, it's summation of forces, or force net, is equal mass and the centripetal acceleration. The centripetal acceleration. So we are talking again about uniform circular motion. Speed is constant. Velocity is changing at a constant rate. In that case, centripetal acceleration magnitude is v squared over r. The direction always pointing to the center. That is, yeah, we talked about that in vectors. When we talk about vectors, you have a circular motion. Here, it's a concept, important concept, in such a circular motion, when the string breaks, the puck moves in a direction tangent to the circle. Yani if we cut the string here, then the puck or this object will just keep going in a straight motion. In a straight motion, it will not go into a spiral motion once it is cut. طبعا لأنه the first law of نيوتن اللي هو جسم الساكن يبقى ساكن، جسم المتحرك يبقى متحرك ما لم تؤثر عليه فرصة تغير من قيمته أو اتجاهه. That's the first law of Newton laws. Now let me here return back here and talk about something very important. Something very important. To force an object to go into a circular motion, something has to force the object to go into a circular motion. For example, we can have a string. Which is tension. So tension will force the string to go into a circular motion. We can have gravity. Gravity will force the object to go into a circular motion. We can have friction. Friction will force the object to go into a circular motion. For example, a car moving in a roundabout. We can have magnetic force. We can have electrostatic. You name it. You name it. But in any circular motion, there must be a source that will force the object to go into a circular motion. If that source disappears, the object will just go into a straight motion. So it's not necessary that you have a string and an object to force the circular motion. And the direction of the force is always towards the center. If it is a string, or gravity, or friction, or magnetic, electrostatic, whatever force, it's always pointing towards the center. So it's not only a string. So as we said, always the force is pointing towards the center. The angle will not change anything because it's a uniform circular motion. Always it is pointing to the center, and always the velocity is perpendicular to the acceleration. Always. And this is the uniform circular motion. So let's study a typical situation, and you will find this in all physics books that teach 101 or 191 physics, the first course in physics. You have an object attached by a string, and the object is moving into a circular motion, and that circular motion is horizontal motion. So it will move like a cone. A cone. We call it a conical pendulum. Conical pendulum. So let's analyze it. Well, here we have theta, and we determine our x-axis, and this is our y-axis. We analyze the tension. So here is the x component of the tension, and here is the y component of the tension. So the x component is tension sine theta. So it will look like this, just to make it. So here is our object, theta. This is tension. So this is T sine theta. And this is T cosine theta. And here I have mg. So we have two equations. In the x-axis, we have T sine theta is equal. T sine theta in this situation will provide the force necessary to force the ball to go into a circular motion. $90 minus theta. No, you can look at it like this. So this is theta. This component is t cosine, and this component t sine. Okay, so in the x-axis, t sine theta will provide the necessary force to keep the ball going into a circular motion. So the centripetal force is t sine theta, and that is equal ma centripetal. In the y-axis, I have t cosine theta is equal mg. So this is my first equation, and this is my second equation. So physics is the two equations. When you have a problem like this, the physics part of solving the equation is writing these two equations. T sine theta is equal m centripetal force, centripetal acceleration, and t cosine theta is equal mg. Based on the problem and the given in the problem, you can decide what to do with these two equations. But the physics lies in these two equations. Now, how to proceed? Depending on the problem. No, it shouldn't be minus g, because summation of forces in the y must equal 0, because the object is not moving in the y. That means t cosine theta minus mg is equal 0. If you look at the book, he will go into derivation after derivation after derivation. But the physics beef in this situation. Can you write these two equations, the first one and the second one? That's the important part. And then after that, based on your problem, you decide what to do. Clearly, you have sine and cosine. If you divide them, you will have a tan, and tension will disappear. You have a tan and tension will disappear, and m also will disappear. Yeah, but that's depending on the situation. Depending on the situation. Yani, easily we can divide these two equations. So you end up with tan theta is equal acceleration centripetal over g. But you don't need to do that all the time, depending on your problem. That is not a pendulum going into a 2-dimension. This is a pendulum going a motion of 3-dimension. So you cannot apply the 2-dimension there. It's not, the pendulum is not moving in the x-axis and y-axis. It's moving also in the z-axis. Let's see another typical situation. And you will find this in different books also. طيب, what is that situation? Well, you have a car going into a circular motion. Going into a circular motion. So let's analyze the forces of that car. Let's analyze the forces affecting this car. So again, we have a circular motion. And here we have our car. Let me just, this is a car. And I must force the car to go into a circular motion. So this is the velocity at this point. And now I need to force the car to go into a circular motion. Which thing that will provide that force? It's the friction force. It is the friction force. And which friction force exactly? Static or kinetic? It is static. And one student, it's a little bit confusing because the wheels, student will say, oh, Ustad, the wheel is moving. So how come it is static? Yes, it is moving because for a short period of time, basically the wheel will just be static against the road. And this is why the car is moving. It will push the road and the road will push back the car. If the car is skidding, then you have kinetic friction. When the car is skidding or drifting, that is a kinetic friction. But for normal motion, it is static friction. Let me give you another example. Suppose that you are running. When you are running, how do you run? Your foot will just touch the ground for a short period of time, and then you will push the ground, and then the ground will push you ahead. So you are running. Although you are running, but at the moment that you push the ground, that is static friction. If it is raining or mud or something like that, you cannot run because it is slippery and friction is smaller, much smaller than the static friction. Anyway, so here, static friction will provide the necessary force in our circular motion. And again, we have our centripetal acceleration pointing towards the center. So, in this situation, our static friction will provide the centripetal force, which is equal m multiplied by centripetal acceleration, which is equal mv square over r. And what is the static friction force? Well, as we did it before, it's mu static multiplied by the normal force. So basically, the physics in this situation is mv square over r is equal mu static, the normal force. This is equation 1. Can you write this equation or not? That's the physics. And what is equation 2? Well, static friction. We know that we just wrote it here. Now, what is the normal force? Well, the normal force is equal mg.
Doctor, I didn't really understand. How did you get the friction SFN in the first line?
That's the normal force. Friction is
Oh,
equal.
yeah, okay.
Yeah, in the book, he write it like this, Newton. Some books will write it like small n. When you write it like n, you get confused with the Newton unit. And when you write it like a small n, so I prefer to write it as force F of n, يعني normal force. عبد الرحمن عندك سؤال تفضل.
Doctor, shouldn't the normal force be in the opposite direction of the friction?
Normal force is vertical يا شيخ.
Yeah, but in this case the friction is towards the center, is not يعني
هاي شوف هذا السيرفيس. This is the car.
okay, yeah, I get it now. Yeah.
And this is the normal force. And there is friction.
Oh yeah, yes, okay. I was a bit confused, okay.
Okay, no problem. In case of kinetic friction, you don't go into a circular motion unless يعني the driver is ما شاء الله يعني an excellent drifter. You need a source if the kinetic friction will provide the necessary force to go into a circular motion, yeah, you can do it, no problem. But the bottom line, no matter what is the force applied to the object, there must be a force that will force the object to go into a circular motion. It's not necessary always it's a string. It could be a string, gravitational force, friction, magnetic force, electrical force, any force. But there must be a force that will force the object to go into a circular motion. And that force is equal F centripetal M acentripetal, and acentripetal is V square over R. Always the situation. Always the situation. So now let's try to solve a problem, this example. To solve the problem, let's see the numbers. He gave us the mass. He gave us the radius of the curvature. And he gave us the friction coefficient. Correct? So here we go. We said mv square over r must equal the coefficient of friction multiplied by the normal force, يعني is equal mu mg, and here m v square over r. Now look at this. Mass will disappear. Mass will disappear. شو يا جماعة معناها الكلام إنه mass will disappear? What's the meaning? That means if condition is the same and you have a car or a bus or a tank going into a circular motion, mass will not affect. Mass has no effect.
So acceleration is equal to friction times gravity.
That's correct.
Is this like an equation that we have to know for other questions as well?
What you have to know, you need to have a force that will force the object to go into a circular motion. And based on that force, you decide the law. يعني mv square over r, if it is gravitational force, then you put the gravitational law here. If it is electrostatic force, you put the electrostatic force here. If it is magnetic force, you put the magnetic force here. If it is tension, you put tension here. So based on your problem. In this situation, it is static friction who is providing for me the force to go into a circular motion. Then I write mv square over r is equal mu mg. M will disappear from both sides. That means no matter what is the mass of the object, it will have the same conditions. You end up with this equation. If you have a small car, large car, a bus, a tank, all will depend on if mu is constant for all objects, gravitation is constant for all objects, r is constant for all objects, and v, speed, is constant for all objects. Mass will not make any difference. That is one. Two, the area is not there. The area of the wheels is not there. Yani if you have thin wheels or you have large wheels, the area is not there, so it will not affect your motion. So if you have large wheels or large area wheels or small area wheels, it will not affect your circular motion in terms of friction. طيب, let's continue. Let's put the numbers. It will flip not because of friction, it will flip because of torque. It will flip because of torque, not because of friction. The centripetal force is the same if you have thin wheel or wide wheel. Again, listen, if you have thin wheel or wide wheel, the centripetal force is the same. طيب, why they use مثلا wide wheels? In order not to flip, because you have torque, but the friction is the same. The force of friction is the same. We are not talking about torque. Torque will flip the car. Torque will flip the bus. But in terms of friction, the force of friction to force the bus or the car, they are the same no matter what kind of wheels, what kind of area of the wheels, as long as you have the same static friction coefficient. It won't matter. We are not talking about torque. We're talking about just friction. طيب, let's put the numbers. So he's asking for what's the maximum speed of the car. So it will be v square is equal mu multiplied by r multiplied by g. So what will be v? Somebody can calculate it for us. Yeah? Yeah. Abdurrahman, be careful, that's v square, so you have to take the square root of that. So it's 13.39 meter per second. So in this situation, you can go up to this speed, and the car will not skid. You can go up with this speed and the car will not skid if you go into a circular motion. Once you exceed this speed, the car will skid and you will lose the control of going into a circular motion. Well, because it's friction. Friction is providing the force, and kinetic friction has a maximum. Kinetic friction has a maximum. So friction can provide you from zero force at the beginning when the car is not moving, and then when the car starts to move, you start to have friction. When the car starts to move faster, friction will increase. Faster, friction will increase until you reach the maximum friction. After that, friction cannot provide the necessary force to go into a circular motion, and the circular motion will break. عادل تفضل يا عادل.
Doctor, I get this, but can you repeat the general concept of how to solve these problems?
The general concept, yes. In order to have a circular motion, you have to have some force that will force the object to go into a circular motion. So,
this question is what is it?
Well, okay, so let me write it here. In order to have a circular motion, your force of the circular motion must equal mv square over r. Right hand side of the equation, it is always mv square over r. Always. Left side of the equation could be tension, could be friction, could be force magnetic field, could be force of electrical field, could be gravitational field, you name it. So based on the situation, whatever source of force must equal mv square over r.
Okay, I got it.
طيب, now he's asking, and this is also a typical question. I find it in almost all the books that will teach Physics 1. This is a typical question. يعني most likely, if you have any situation, he will ask you this kind of question. Suppose the car travels this curve on a wet day, يعني coefficient of friction changes, and the car begins to skid the curve at 8 meters per second. What can we say about the coefficient of static friction? Well, we just very simply write our equation. Coefficient of static friction must be equal V max over Rg. We just use this one. It's just this law. And we put the numbers 8 squared divided by 35, 9.8. And if you do the calculation, 0.187. That's the coefficient of friction when it is raining. When it is raining. More than this, the car will skid. The friction, the static friction, cannot hold the car anymore, so the car will skid. Any question? طيب الحين let's talk about another typical situation, and you will find it in all lectures or all books. They call it the Band Roadway. And what is that situation? Well, we have a car and the road is not horizontal. It is banged with an angle. It is banged with an angle. So how to solve it? Well, let's draw it first. So this is theta, and this is the x-axis, and this is the y-axis. This is my car. So first of all, I have the force of gravitation. It's mg. And then I need to draw my normal force. My normal force. So let me just, whoops. So my normal force is perpendicular to the surface. This is my F normal. So this is my y-axis. This is my x-axis. And according to this, let's analyze the normal force. So this is theta, and this is theta. طيب, let's analyze the normal force. This is the y component, and this is the x component. So this is Fnx, and this is Fny. So Fny is equal Fn cosine theta, and Fnx is equal Fn sine theta.
Doctor, won't you put like minus Fn sine theta?
No, it's just the component.
So
minus and plus does not affect anything. I'm here just talking about the component. أحسنت يا يمان. Fn, the normal force in the x-axis, is responsible for the circular motion. Is responsible for the circular motion. So now let me write my equations. Fnx is equal Fn sine theta, and that is equal to mv square over r. That is equation 1. طيب, what is equation 2 يا أستاذ? Equation 2 إنه Fn cosine theta must equal mg. We don't need, that's a good question, Abdurrahman. We don't need to analyze mg because mg is in the y direction. I assume this is my x-axis and this is my y-axis. mg is in the y-axis, so I don't need to analyze it.
Doctor, I also recall that when something is on a slope, you take the y-axis and x-axis on the slope. I think we did that in the
That is
previous
correct,
question.
but that
Maybe
is
not today.
that is correct, but that is not the rule to solve all problems. When you take your axis, you choose the axis to let you solve the problem easily. So in this situation, if you take the x-axis, for example, if you take the x-axis like this and the y-axis like this, still you will solve the problem.
Also,
But
it
which is
doesn't matter.
easier?
Yes.
Which is easier?
Yeah.
Yeah.
Good.
But you will end up with the same solution. Always you choose your axis to help you solve the problem the easier way. So again, when you have a banked street or a banked road, those are the physics equations. Now, depending on your problem, you determine what to do with these two equations. But if you write these two equations correct, that means most of your problem is correct. Here there is no friction. It's just banked. You are a civil engineer who has been given the assignment to design curved in such a way that the car will not have to rely on friction. There is no friction here. If there is friction and banked, then you need to consider both forces. But in this problem, your life is much easy. It's just the x component of the force, of the banked force, will be responsible to do the circular motion. So let's try to put some numbers. Suppose the designated speed of the road, he gave us the speed, and the radius, he gave us the radius. Determine the angle which the roadway of the curve. Well, we just apply our equations. Pay attention here, you have sine and cosine, so we can divide the two equations. So F normal force sine theta divided by F normal force cosine theta is equal, again, M will disappear. That means if you have a small car, a large car, a tank, a bicycle, anything that moves in a circular motion in a banked street, the mass will disappear. The mass will disappear and we end up with V square R G. So that means tan theta is equal V square RG. We put the numbers 13.4 square divided by 35, 9.8. What is theta يا شباب؟ Well, a tilted plane is the banked street. According to this axis, x and y, the force responsible in the x, it is F sine theta, not cosine theta. According to this analysis, this is the x-axis and this is the y-axis. The force in the x-axis is F sine theta. Be careful. Yani it's not memorizing. It's just analyzing each situation based on the circumstances. Theta is equal 27.63 degree. What does that mean? Well, that means if you want the speed of your banked road, even if it is snowing, even if it is ice, when you do a road that is banked with an angle of 27.63, then the cars can go at this maximum speed even if it is ice, no friction, zero friction, and still the car will not skid. And still the car will not skid because of the circular motion. It can skid because of lack of friction. يعني somebody can ask Ustad طيب, why we need friction in this situation. لاحظوا, when the car goes into a circular motion, we need this component that will provide the circular motion. But if the car is not fast enough, there is also a component of gravitation. Now we take, this is an x, this is y, and then there is this component mg sine theta will cause the car, if there is no friction, will cause the car to skid to the bottom. But that's a different problem. Now we are talking here about the maximum speed that will sustain a circular motion. Yani if there is no friction and you put a car on this side, it will just skid to the bottom if there is no friction. But that's not our problem. Our problem, we need to see what is the maximum speed that the car can go without friction and still it will stay in a circular motion. Yeah, of course, to calculate the friction, you need the normal force. But that's a different situation. This is different. Different situation. طيب, now we come to this typical situation. Also it's typical. Also you can find it in several books. And pay attention because yeah man, when you open any book any book, any author, any edition of even the same book, you will have the same example. You will have the same physics example. It could be different example, but the physics is the same. That's correct, but most of the time there are some problems that is preferred and they repeat. They repeat all the time because it has a lot of physics concept in it. طيب. What is the typical problem? Well, suppose that you have an object going into a vertical motion, a vertical circular motion. Vertical circular motion. No matter how does it look, is it a boy on a wheel, or is it just an object attached to a string, and the object is going into a circular motion? Let me just try to draw a circle first. So this is the center. The object can be here, or the object can be here. So a typical situation, we need to study the object, the forces on the object at the bottom, and we need to study the forces on the object on top. So this is R. طيب. Remember when we talked about you are in a car and the car is accelerating in this direction. Where do you feel yourself going? How do you feel this force? Backward. So this is the real force, and this is the field force, or we can call it a gravitational force. Gravitational motion force. Why I'm going this avenue? Well, just you will see in a minute. طيب. Now we see the other situation. You are in a car and you brake. So that's acceleration, and that is force. Where do you feel the gravitational force? Like what pulls you to the front? You feel it to the front. We can give it a name, force gravitational dash, to distinguish it from the real gravitational force. So this is force gravitational dash. Okay? Now we come to our situation. We are studying the motion at the bottom. So where is mg? Pointing down. Where is the tension? Pointing up. Where is the real centripetal acceleration? They are all vectors. And where is the gravitational force due to the centripetal force? It is pointing down. Again, look at this, and we follow the same methodology. The real accelerating force is left to right. Where do you feel the force? Right to left. The force, right to left, you are braking. Where do you feel the force? You feel the force left to right. The real force, when you have a circular motion, it is pointing towards the center. The gravitational force is pointing away from the center. That means in this situation, let's apply Newton's second law. F net is equal ma net, and in this situation the tension must equal mg plus ma centripetal. Or, in other words, if you cannot see it in this way, you can see it as tension minus mg is equal ma centripetal. لاحظوا, pay attention. When the object is not moving, it is just hanged up, we know for sure that tension minus mg is equal 0. So we are familiar with this equation. Now we have a motion, so that means tension minus mg must equal ma centripetal. Well, did you follow this example? Well, we apply the same methodology. If you are not convinced, then we come back to this equation. T minus mg is equal 0 when there is no motion. When there is a motion, then T minus mg is equal m multiplied by the centripetal acceleration. The centripetal force is pointing towards the center. That is correct. So the object will go against the force. Like this example and this example. And this is typical. You will find it in all books. Now let's repeat the same thing now about our chair. Here, now the supporting force is provided by the normal force. And we have gravitational force and we have the normal force, the centripetal force. Previously, when we write the equation at the bottom, we will write normal force minus mg must equal to 0. Because the brother Abdurrahman, we said in a circular motion there must be a source that is providing the force necessary to do a circular motion. Here is tension. Here there is no tension, it's a normal force. In this example, it's just a normal force. When the moon is moving, circulating Earth, there is no tension and there is no normal force. It's a gravitational force. The seat is not touching the ground. The seat is attached to this circle, to this wheel. Here, the boy is sitting on the seat. The seat is providing the normal force, and there is gravitational force on the boy. So, if there is no motion, what is the equation? The normal force minus mg is equal to 0. Is the situation when you have a box and here is normal force and here is mg. That's the situation without circular motion. طيب, we add circular motion, so then our equation becomes normal force minus mg is equal ma centripetal.
Okay, Dr. The MA centripetal is the force of the FC, right?
That's correct.
Okay, if the FC and the Fn are in the same direction, then it shouldn't be this equation. It should be Fn plus Fc is equal to mg.
In this situation, we are not going to deal with the centripetal force. We are going to deal with the field gravitational force. Yani the boy has a force Fc, but where he is going to react to the force, with the direction of Fc or opposite to the direction of Fc?
He's going to react opposite.
Opposite. So for that we add it to mg.
So it's actually Fn is equal to mg plus Fc.
Exactly. At the bottom.
Uh,
That's at the bottom.
oh,
It will change at the top. It will change at the top. Now we will talk about what will happen at the top. Now, let's see what will happen at the top. At the top. Exactly, Muhammad Saeed. FC at the top. That is FC. And we have the tension. And we have mg. That's correct. Fc is pointing down, the tension is pointing down, and the gravitational force is pointing down. So the field force is pointing up. Exactly. So in this situation, mg minus t is equal 0 when not moving. When it is moving, it's mg minus t is equal ma centripetal. يعني tension is equal mg minus ma centripetal. mg is always down in all cases. So that's the situation when we have tension. طيب, what is the situation when we provide a normal force? No, yeah, brother, it is always mg minus t. Did we ever do it like this? Did we ever said mg plus t is equal 0? As vectors, yes, we can write it as vectors, but as y component, we never wrote it like this. It's mg minus t is equal 0. And check the notes. We never wrote it in the y as mg plus t. We can write it mg as a vector plus t as a vector is equal 0. That's correct. But as vectors. But as components in the y, we never wrote it mg plus t. Now the situation, when you are at the bottom, you add the centripetal force or the field force to the gravitation. When you are at the top, you subtract. So we did that for the tension. Now let's do the same thing for the normal force. Well, in this situation, this is the normal force. So in this situation, the normal force minus mg minus the normal force is equal ma centripetal. يعني the normal force is equal mg minus ma centripetal. And this is for top, while this is bottom. صحيح خلصنا احنا. Let me stop the recording. طيب